So no doubts.
No doubts. Great. So the last lecture we ended with the concept of I think triangle law in 3D, right? Direction cosines, correct? So
So I
we,
had a doubt in the homework.
which one?
So the third sheet which you gave, the
Ah.
third question, I had a doubt in that.
Let me check.
Yeah.
Third sheet, third question. Okay, you're solving the third sheet directly. Yeah? That's level 1, right?
So the one after that,
The vector objective practice, that's one.
the unit vector question, if A, B, and C are unit vectors.
No, no, like what is the name of the sheet? Vector sheet, vector questions, or vector objective practice?
Vector objective practice.
Ah, okay. Let me check. Okay. So we have two vectors, and if u is a unit vector, then what is the maximum value of the square? Oh my God. Okay, so that you can leave as of now because I haven't taught the triple product as of now. Okay, so that will be the last miscellaneous topic in this chapter. Okay, so don't worry for that. Don't try that as of now because that is the mix of all questions and those are typically very challenging and difficult problems. Attempt after this chapter is over, okay? Because you will find many concepts, interlinked also in that uh, objective practice. All
Okay.
right, so we'll do something like practice. So we'll do practice today again. So given any vector, like when I give you a vector, what I give you some magnitude and some direction, right? So given a vector, if someone is giving you some vector, what they give you is a magnitude and a definite direction, right? So both the things are there. You can see clearly this arrow is representing not just magnitude but also a direction. Okay. Now definitely, if someone else is also going the same direction, let's say another person is moving in the same direction, and this person is moving with some magnitude. So his magnitude is, let's say, b. Okay. And direction is same as a. Now what you understand is the b vector is not known, rather its a magnitude is known. So let's say the direction of b is not known, but it is known that it is parallel to a. So for example, if I tell you a person is walking along x-axis, a person is walking along x-axis with a speed of 2 meters per second. So 2 meters per second is what? Magnitude of velocity, correct? 2 meters per second is called speed, right? So what is the speed of the person? 2 meters per second. In which direction he is moving? X-axis. Okay. So if I wish to define the velocity vector, then how we can define it? How we define the vector? So magnitude and then direction. So you say 2 meters per second I cap, which means this person, this boy is moving in the x-axis direction with a speed of 2 meters per second. So this is called the vector representation. Okay. And now this is called velocity vector. So velocity vector always represents both magnitude and direction. What about the speed? It's a scalar. And what scalar represents? Only magnitude. That is obvious. Now, when I say x-axis, what you did, you multiplied with I cap. What if I would have mentioned y-axis? What we need to do in such case? How to represent the
J cap.
velocity? J cap. And if I mention that as Z axis, then what will it do?
K
K
cap.
K cap. Now, what if I mention that as a vector? Now coming here. Now I'm not saying X, Y, Z. What I'm saying, the B is moving parallel to A vector. Then how to represent the B vector in terms of A vector? What we can do? So I want to relate B with A. I want to relate B with A. And here comes the actual concept. And what is the concept? The most important concept in physics. If two vectors are parallel, if two vectors are parallel, or I can say like parallel, if two vectors are parallel, tell me guys, what will be same for both?
The direction.
Exactly. Now, can we say that magnitude must be same? Can we say that? Can we say that magnitude must be same?
No, sir, not necessary.
Exactly. We have no guarantee of length, but do we have guarantee of direction? So if two vectors are parallel, then what must be same?
Direction.
And what may be same?
Magnitude.
Correct. So we cannot rely on the magnitude, but we can rely on the direction. Am I right? So that is the first takeaway. The moment we say two vectors are like parallel, the one thing that we can say for sure, and that is they must have same direction. Okay. So to understand this and to develop the intuition, let's say the A vector is having length 3 units, and let's say the B vector is having length 2 units. The unit could be anything. It may be meter per second, it may be meter, it may be second. I mean, not second, it may be any physical quantity, which is a vector. So now 3 and 2, let's say if I divide this into 3 equal parts, and if I divide B into 2 equal parts, can we say each part will be having same length? Now, so a length of 3 units divided into 3 equal parts. What will be the length of each part?
Sir,
1
one.
unit. 1 unit, right?
1 unit.
And if similarly, if we divide the B vector into 2 equal parts, what is the length of each unit, each part? Again, 1 unit. So you need to realize something, that the moment you cut into 3 parts, every part will be equal vectors. Can you see that? Are these vectors equal? Equal means they have same magnitude and same direction.
Yes, sir.
Can we say that each part will have same magnitude and same direction?
Yes, sir.
So we cannot say that A and B are equal, but can we say that the A divided by its length and B divided by its length must be equal vectors? Does it make sense to you guys? Tell me.
Yes, sir.
Prashansa and Shreya and Rugved, please tell me guys. I mean, your
Yes,
Yes.
sir.
understanding with this is clear?
Yes, sir.
Okay. So this is a very important concept in physics. Its entire physics is based on this. And what it says that if two vectors are in the or having same direction, the thing that I can guarantee is that their unit vectors must be equal vectors. Because the definition of equal vector says what? When we say two vectors are equal, when we say two vectors are equal, if
Magnitude and direction is same.
they have same magnitude and same direction. So if they have same length and same direction. So here direction was not an issue because direction is anyway same. We were doubtful about the length, right? But the moment you divide the vector by its its length itself, what you obtain is called unit vector. And now they will have same magnitude and same direction. Do you realize this? That they will have same magnitude and same direction? Tell me, guys.
Yes, sir.
I think you are not confident. That everyone is not sounding confident about this. Siddhant, are you confident this is correct?
Yes, sir.
Yes, sir.
Very good. So this is important. Like if two vectors are having same direction, I'm not sure how big the length is, but once I divide by their own length, I end up getting a unit vector, and we know that every unit vector will have same magnitude, and so direction was same, length is now same, so we can say they are equal vectors. So that's the rule. If two vectors are parallel, then their unit
Direction.
vectors, their unit vectors or vector unit vector actually must be equal vector. So that is the most important concept. How to relate two vectors once you know they have the same direction. Okay. Once you know they have the same direction. Understood? So if you want to write A in terms of, if you write A vector in terms of B vector, how you can write? Mod of A upon mod of B into B vector. This is a length, this is a number actually, it's a magnitude, ratio of length into some vector. Or you may write B as so given one vector, we can express the other vector, though I was not. So let's take some example to like reinforce this concept in your brain. So we'll take a very nice example. Of course, all examples I will take will be challenging, not very easy, but really worth of learning. So in physics, we deal with cube and cuboids a lot. So question pertaining to cube and cuboids are going to stay here. And therefore, we have to make ourselves comfortable with the cube and cuboid type of problems. The moment you see cube or cuboid, what comes to your mind? I will tell you what comes to my mind. But as of now, mathematically, do you see something?
So number of sides,
Right.
number of
So-
edges.
Right. So what I see is, I see a coordinate system. I see there are three mutually perpendicular lines intersecting at a point, and therefore I can see origin also. Then I can assign the x and y and z axis, right? So can I say this as y axis, and then this becomes the z axis, and then this becomes the x axis? So I have just given you a cuboid, and then out of your own imagination, to assign the proper coordinate system x, y, and z. Okay. So what next? The next thing is we need to represent the length of each side. For the sake of writing, I'm taking the length as this as 3, this as 4, and this as 5. That's okay. So you know the length. What we do next is we are going to name the corners. Let's call it A, B, C, D, E, F, G. Okay. So now I hope you can see all the corners A, B, C, D, E, F, G. Okay. So what we'll do before we start solving problem, we'll try to learn something about keywords or cube. So I will draw some line and we call this as, let's say, a vector OE vector. This is which vector? OE vector. You are supposed to express OE vector in terms of I cap, J cap, and K cap. And the rule is very simple. We have to use the triangle law, but again, that is not required. The simple job that you have is start from O, end at E, but choose the path along the edges. And as you walk, keep on writing the I, J, K. So I will show you one of the path, but you are free to choose a path of your choice. Okay. So look at this. Can we go from O to E like this? Can we go?
Yes, sir.
But this is not the
Yes,
only
sir.
way. I can go this way, this way, this way. I can go this way, this way, this way. I can go this way, this way, this way, this way, this way. I mean, there are many ways in which I can reach. Now, what is the beauty of walking? As you walk at any instant, your direction will be either parallel to x-axis or y-axis or z-axis or reverse of the three, minus x, minus y, minus z. And we know that for a person walking along x-axis, the direction is called I cap, for y j cap, and for z k cap. So tell me guys, what is your answer when you walk from O to E along the edges? Make sure you use the proper direction, unit vector, while you walk. So anybody would like to say something? How to write the OE vector?
Five I cap plus 4J cap plus 3K cap.
Once again, repeat. Repeat
Five
the
I cap
5 I cap, very good,
plus 4J cap
plus 4 j cap,
plus 3K cap.
excellent. This is the right answer. So 5 I cap, so you can work like this. You go O to A. So O to A is which direction? X, Y, Z, or reverse of what is the direction of O to A? What is the direction of O to A, guys?
So Z. You can.
Z. So, and how much is the length?
3.
3 Z. K cap, right? A to B. Which direction? What is the A to B direction? Tell me, guys.
X.
X direction. And what is the length?
5y.
So 5 I cap. And then B to E. Which direction? B to E?
Y.
Y. So, and what is the length?
3k cap.
No, length in the Y is how much?
3.
No.
Oh, sorry, 4.
Yeah. Correct. And if you rearrange, you can add 5I plus 4J plus 3K. Right? So it's not very difficult. It's not very difficult. This is not the only question. Let's do some more problem. We'll practice a lot today on the Q and cuboid to master it. Who will tell me the GE vector? What is the GE vector? Fastest finger first. To reach G to E, you how many steps you need minimum?
So 2.
So two steps.
Just
Two steps.
Very good. So how you are going to walk? Tell me.
So 5 I cap plus 3 K cap.
Exactly. That's correct. 5 I cap and 3 K cap. So GE vector turns out to be 5 I cap and 3 K cap. Excellent. Okay, guys. So next, who will tell me this? CD vector. CD vector. What is CD vector? Rugved, are you getting this?
Yes, sir. Is the answer minus 5 I cap plus 4 J cap plus 3 K cap?
Very good. So minus 5 I cap is correct. And then what next?
Plus 4 J cap
Very good. And then
plus 3 K cap.
excellent. So you have to just walk from C to D, right? And the moment you walk from C to D, you're done. So this is not very difficult. Just you need to understand that how I need to walk. And you can choose the direction as you wish. No matter how many times you repeat the path, eventually you come back to the same point with the same answer. So now the question is, why are we doing this? Why are we doing this? That's the question. Let's see, why are we doing this? So let me do this keyword again. So in this keyword, okay, see, no one is going to tell you that use the vector to solve this question. No one is going to tell you. So let's say this is a 3, this is a 4, this is 5 actually. So first try to realize what we are doing. We have a keyword given, nothing is said to us. Okay. And then they tell you something. Let's say I attach a thread between the corners. This is the thread. And imagine an insect is crawling on the thread with a speed of 2 centimeters per second. That's simple question. This is the question given. The insect is crawling along the diagonal because I have attached a thread, maybe some spider, and it is going with a speed of 2 centimeters per second. That's question someone asked. Let's see. And if I ask you what is the angle between the motion or the velocity of the insect and this edge, I want this angle for some reason. I have no idea, but I just want this angle. Can you tell me what is this angle? So that's the question. Or I may ask you, can you express this if I choose? Okay, now what we do is in physics or in mathematics, vector is a method to attack problem. So they will give you problem. You can convert into a vector problem. So if I just give you a very simple problem like this, and if I ask you that convert into a vector problem, what we'll do is we choose the proper coordinate system first. Now, no one is going to tell you how to choose it. This is a very common sense thing. So you will apply the common sense and you will choose something suitable to your calculation. Now, the moment I choose X, Y, Z the way I have chosen here, I convert this into a coordinate system. Again, no one has said me do this. I am doing this why? Because I know if I can express like this, I will be able to use the vector notation. The first step is done. I know that the ant is moving or the insect is moving along the diagonal. Let's call it A. And we have already learned how to write OA vector. What is the OA vector?
Sir, 5 I cap plus 4 J cap plus 3 K cap.
Exactly. Now this is the vector, but let's say I want to know the what is the OA cap, what is the unit vector in that direction. I just want direction. What is the method? Take the vector and divide by its own magnitude. You will get a unit vector, and that's the notation. The better notation is E cap OA vector. You can write like this, which means what is the unit vector of vector OA? How to read this? Unit vector of OA vector. And now we know what is OA. You have already identified. And you are going to divide by OA. What is OA length? So how we find the length? We square and add the coefficient of I, J, and K, right? So what
So
we do here?
root 50.
Yeah. So 25 plus 16 plus 9. And definitely it is root 50. Which is how much? 5 root 2? So we can write like this. So I got the unit vector. I'm not writing the subscript because it's obvious what I'm dealing with. Now, do you remember that if someone moves in the x-axis, you write I cap. For y-axis, you write j cap. So this direction having a name E cap. So how to write the velocity of the insect? What should we write here? 2 centimeter per second E cap. Similarly, the way we used to write I cap, j cap, and k cap, because now my unit direction, my unit vector in the given direction is E cap. So multiplying with E cap will give me a vector notation. So now this is how we express a number into a proper vector notation. To move forward, you can also substitute the value. And what was that? 5 I cap. Understood? So the final answer is root 2 by 5. I just multiplied root 2 and 2. 5i plus 4j plus 3 into, okay, that's it, centimeter per second. This is the answer of velocity vector. Is this clear, guys?
Yes, sir. Clear.
Yes, sir.
So this is how we express the answer. Given some value, we can convert into proper x, y, and z coordinate. Okay. So going forward, we will be using this keyword answer, keyword problem as often as possible to solve some of the challenging problems. Okay. So one problem before we move to the next concept, which is very often part of the keyword problem. So let's say we have the again keyword 3, 4, 5. I will keep it 3, 4, 5 always. And what I'm going to ask you, that find the sum of vector EO plus AF plus GB plus DF plus age. Can you find the sum of these vectors? And then find the magnitude. So do this question else. So I hope the question is clear.
Yes, sir.
So just
Yes, sir.
you have to express everything in vector form, I, j, k, and just add them and then take the modulus.
Done, sir.
Sir, done.
Okay, very good. So what is the answer, guys? How much is the magnitude you got?
Root 90.
9. Everyone is getting the same answer?
19. Sir.
Actually, root 19. Okay.
Sorry, root 181. Sir.
181.
Sir, I'm also getting it as root 181.
Root 181. So I think that looks promising answer. 19 is not promising. Okay,
Same one.
181. So all are like getting 181. So anyone who is getting different from 181?
Sir, can you show it once?
Yeah, of course. So E to O, EO, what is U? It's simple. You have to go from E to B. Let's go down. So minus 4 J cap, minus 5 I cap, minus 3 K cap. That's first part, right, guys? I like one by one. What is AF now? A to F. Ah, that's easy. 5 I cap. Okay, 5 I cap. Then go to that 4 J cap and minus 3 K cap. Am I right? What is the GB? Go to G to B. So I'm going from G to F and F to E and then E to B. I hope that's okay. 5I plus 3K minus 4J. The GB is done. DF. DF. Oh, that's easy. D to E. E to F minus 3K. Because you are going reverse to the Z axis. DF is done. What is AG? A. Okay, fine. That's easy. Minus 3K cap and 4 J cap. Now tell me if you're doubting these values.
Sir, no doubt.
Then we're done. We can add all I. Just cancel anyway. So we are getting 10I, right? 10I because 5I and then 5K. Let's look at J. Minus 4J plus 4J also cancels. So are we getting J, any value of J left? No. So there is no J. Oh my. K is left. 336 plus 9. I think this is the answer. If you take the mod, it is very good. So everyone who has got 181 is the correct answer. And with this, you have already having a good command over the Q problems. You know how to deal with the Q problems, how to write vector notation. So of course, once I will teach you something like relative velocity and so many other things, we can again come back to this position and we can solve it. But can we do something more with the vector? Something from mathematics, something which we have seen before, but not realize that we can do like this. The answer is yes, we can do a lot more with vectors and especially the triangle. So let me show you something interesting about triangle. So you all have studied about the internal and external division of a line, right? In mathematics. I hope everyone has heard this name. Internal division and external division. So let's
Yes.
say we have a point A in space and we have point B in space. And let's say you have learned that we can divide this into m/n ratio. So given the coordinate of A and given the coordinate of B, we can find the coordinate of the intersection point. That's called C. So this is what we have learned in maybe high school. Try to understand this, what exactly we are trying to achieve here. We can draw perpendicular like this from here. So this is, of course, if I call this as x1, y1, and if I call x2, y2, what is this value? 0, y1. And this is what is 0, y2, correct? What is this value? x1, 0. And what is this value? So my simple question is, what is given x and y, given that the ratio is m/n, What is the x and y coordinate? I'm looking for x and y coordinate value. So what I need is x and what I need is y. Now, from similar triangle, you know that the ratio m is to n, if you divide the line into m is to n, the projection will also divide into m is to n. So even this is m is to n, and even this is, that's a fact. Everything is m is to n. So can you solve it without knowing mathematics, just by scratch, like taking the ratio and finding the coordinate? So here you can find easily. No? What is the m is to n? So this length is how much? Can we say x minus x1? What is this length, guys? Tell me. What is this length?
x2 minus x1.
X2 minus x. Correct?
Oh, yes, yes, sir. x2 minus x.
X2 minus x is the length. Am I right, guys? And the ratio of the length is how much? X minus x1 upon x2 minus x is m is to n. Am I right? I hope am I right. Okay.
Yes, sir.
Well, if this is the case, can we rearrange or cross multiply? Nx minus nx1 equals to mx2 minus mx, and if you rearrange further, n plus m into x is nx1 plus nx2, and therefore the x turns out to be how much? mx2 plus nx1 divided by m plus n.
By
And
m plus n.
this is what you studied in high school, right? The division formula of a line, and it's not difficult. We can do it by common sense. Like, no need to mug up the formula. You can just do like this. Okay. Similarly, I can show you for the y-axis also. So how you can write for y-axis? y1 minus y upon y minus y2 is m is to n. Can I write like this? Just let me know, yes or no. If you feel comfortable, say yes. Yes, I will again explain. So can we write like this? The length ratio. Hello guys, tell me. Can we write like this? Yes or no?
Yes, sir. Yes, sir.
Yes, sir.
So do the same thing. Multiply ny1 minus ny is my minus my2. And if you rearrange, you're done. So what I'm trying to show you that you are not supposed to remember or mug up. Learn the derivation the way I do. So let's say as a beginner, I never try to mug up anything. What I do is I try to derive from the scratch. By drawing proper diagrams, I can get the answer. Now, the entire idea which you have done here in terms of writing so many things, this can be done even in terms of vector notation. So that is what we are trying to or going to learn. How to express these answers in vector notation. In vector, instead of coordinate, what do we write? I hope you remember. We write position vector. So this is called the position vector of A, right? Similarly, can we say this as position vector of B? So instead of writing the paired coordinates x1, y1, x2, y2, I am giving you r1, r2 as direct vectors representing the position of the point in space, namely A and B. And so my question is, can you guys tell me what is the position vector of the point C? So we are trying to find the r vector given r1, r2, and it is known that the C is dividing internally the length or the line AB in m is to n. So now my question has changed from the scalar to vector. Okay. So in maths you have done this, right? So how to do in physics? So we have to use a triangle law, and triangle law will give you both answers at the same time. How? So let me show you. Here only we have space. I can use the space here to solve. Just in case if you come across any doubt, raise your hand. I will be asking, explaining again. So the same method. I mean, to make it simple, I'll keep a consistent direction. Okay. So you can see AC, you can see CB. So can I write AC by CB is M is to N? My first step of solving question. Okay. If you're comfortable till here, raise your hand or say yes to me. Everyone is comfortable
Yes.
here till here?
Yes.
Yes, sir.
Now, so far there is no vector concept. I'm just writing the length ratio because it's given. Now the problem is I cannot write vector here and here. Why? Vector cannot be divided. You cannot divide directions. Okay. That's the problem. So we cannot write a arrow now. So to make it feasible into a vector notation, I need to bring in the numerator first. Now this is fine. So what I'll do next? I'll put an arrow. And what it is trying to say? That the direction of AC and direction of CB are same, because M and N is a number which is positive. So what is this ratio representing? It is saying that the length of AC is M upon N times the length of CB. Or you can say, if you multiply the length AC N times, and if you multiply the length CB M times, both becomes equal. Oh, that's nice. So from the scalar definition, I convert it into vector notation. Now that is the second step. Okay. But once you have AC, you have to think of triangle law. So can you guys think of triangle law in the first triangle containing AC? So which two other sides makes the triangle OAC? In triangle OAC, can we express AC in terms of R1 and R? Yes or no? Can we guys express? Tell me.
Yes, sir.
Okay. So if you can, so go ahead and tell me. How I'm going to write AC?
So our OC is equal to OA plus AC.
OC is equals to OA plus AC is the right answer. Very good. Excellent. But what we are looking for? We are looking for AC, right? So from triangle law, we got this relation. Then what is AC? OC minus OA. Do we have the better representation of OC and OA? Yes. What is OC? What is OA? And I'm done. If you are with me, raise your hand. Or say yes.
Yes, sir.
Yes, sir.
So anybody having difficulty? I mean, don't hesitate. Just say yes or no. If you have difficulty, I'll explain again. This part is clear to all of you? Okay. So in triangle OCB, tell me what is the relation? What is the triangle by the way? What is the triangle?
So our OB is equal to OC plus CB.
OB is equals to OC plus CB. Very good. So what is CB now? Because we are looking for CB now. So what is CB?
OB minus OC.
Yeah, which is R2 minus R. Am I right?
Yes, sir.
Now we have the answers. AC and CB. Let's call it Equation 3. So from 1, 2, and 3. No, from 2 and 3. 1, 2 we have done. From 2 and 3. I have a little space left. Tell me, guys, what I can write now. So can I write n multiplied by r minus r1 is m multiplied by r2 minus r? Can I?
Yes, sir.
And now what we are looking for? We are trying to find what? R vector. Okay, we are trying to find the r vector, and therefore it is only about rearrangement. The r turns out to be m r2 plus n r1 upon m plus n. Please do rearrange and get yourself this answer. It's a really nice way of taking care of the vector notation. And why the vector notation is important? Because in one dimension, you have to write answer for x separately, y separately, z separately, then repeat the process for x, y, and z. But here we can directly write at one go all the three values. I'll show you how. Okay, is this clear, guys?
Yes, sir. Clear.
So the r vector is how much? M r2 plus n r1 upon m plus n. Okay, so that's really interesting way of writing the position vector of a point which divides the line joining the other 2 points in the ratio m:1. So let's do some application. So if I give you a point, let's say 2, 1, 3, and if we have point, let's say -1, -2, and 6, and now these are some random points. I don't know how it is in space actually. I have no idea, but that really doesn't matter. And then I have point, let's call it A, let's call it B, and I would like to know the coordinate of the point C, which divides in the ratio of 2:3. That's my only goal. So can you tell me the coordinate of this point? Now, if you try to write in separately, you can write separately, but the better way is you can write in vector notation. How? The origin is not shown. You can choose origin anywhere, and then you know what to be done next. OA, OB, OC, and I'm looking for OC, right? I'm looking for this vector R. So can we write R equals to twice of OB vector plus thrice of OA vector upon 5? If you have doubt, tell me. Is it the right way of writing? Yes or no, guys? Tell me.
Yes.
So R vector turns out to be how much? 2i's of OB. What is OB? See, I will tell you a shortcut. Don't write IJK. Just write as a -1. Keep it like this one. It's a simpler way of writing the vectors. You can do this operation at once for the entire vector like this. So this we can write as -2 and +6. How much? So we can add the components one by one. So -2 + 6, comma, -4 + 3, comma, 12 + 9. Am I right, guys? Just tell me.
Yes, sir.
We are just multiplying and adding the components one by one. So what I'm left with? 4, 1, 21. I got this answer. So if you want coordinate, you can just leave like this. But if you want You can write as 4 by 5, comma,
-1.
how much? -1, correct. So 4 by 5, comma, -1 by 5, comma, 21 by 5 is the coordinate. Or if you want to write in vector notation, you are ready. 4 by 5 I cap -1 by 5 j cap plus 21 by 5 j cap. So this is how we can solve the question of finding the coordinate at once. You can do the manipulation of all three components at the same time. That's totally up to you. So that's a one application of triangle law. Triangle law is so powerful that we can derive various geometric theorems. We can derive various trigonometric identities using idea of only triangle law or vector idea. So I'll show you as we progress in the course. I'll show you how to derive various trigonometric identities using vector notation. It's so powerful. So vector is not just a chapter. It's a way of life. It's the most advanced language in which the various phenomena of world can be expressed. And as you progress in your mathematics course, you will come across a chapter called Matrices. Have you heard this name? Matrix.
Yes, sir.
You might have heard the name matrix. Okay. So matrices is another way of learning vector. Okay. So matrices takes care of any dimension. Let's say in real life, we are confined to 3 dimensions, X, Y, Z. Now a matrix is a way of dealing with n dimensions. So that's why we call array. So the way of interpreting a matrices is that you deal with multiple dimension, and you may be wondering, so what is the meaning of dimension? What is 4 dimension? What is 5 dimension? Those things are not very difficult to understand. But as we progress in the course, I'll explain you what is those dimensions. Not very difficult. So this is clear, guys, how to do this. So I'll just keep this example.
Yes, sir.
And we'll move to the next derivation quickly.
So can you show the 4th slide once? I just wanted to see you. Okay, sir, fine.
Let me put a heading: internal division. See, if you want to learn only the vectors as per the physics syllabus, it's very small chapter. But the entire physics is written in vector form. So my idea is to present you the entire physics through the lens of vector algebra. How physics will look like if we have only one mathematical tool, and that is vector algebra. So that's why try to grab as much as possible. These all things are bonus. Same thing you will study at the end of math syllabus called vectors and 3D in the end of class 12. But if you learn now, you will become powerful. So if you want to make yourself powerful, make sure that you are powerful with vectors. Very few students, those who prepare for JEE, they try to understand vector. They somehow use some of the formulas with very less intuition about vectors. They don't have much intuition what they are doing or why they are doing. If you guys can develop, I will be really or super happy. So the next derivation is, of course, external division. And I believe that the steps which I described, using those steps, can you derive the formula for me? Of course, I will do at the end in case if you don't do it. But hopefully, it won't be a very difficult task for you guys. So try to understand that every formula is derived from scratch. So given these position vectors, what we do is we extend the line, because that's the whole idea of external division, and we call C. I am looking for the coordinates of C And how we write the external division? What is the m is to n here? The AC upon BC is m is to n. That's the meaning. You start from the left end to the extreme end C, and then B to C. So you go from A to C completely. A to C, and then you go B to C. This is called the external division. M is to n. So can you tell me the coordinate of R, the C point from the origin, given the coordinate of A and B, which is R1 and R2? So R1, R2 is something known to you, given to you, and you are supposed to derive the R coordinate. If you want to see back, you can see once again, I'll show you. Look at the steps of derivation. In my first lecture, I emphasized that derivation is a way to go in physics. If you don't do it, you will find entire physics difficult. Else, it's easy. So derivation means don't try to mug up anything. Try to derive and keep your brain clutter free. No need to remember anything. Just derive as and when required. So I'm giving you 5 minutes to derive and tell me the answer. Then I will solve the question. Your time starts now. Question is clear, guys? Yes or no?
Yes, sir, it's clear.
Okay, great. So go ahead and tell me the answer.
Your voice is not coming.
Am I audible, guys?
Sir, now you are audible.
No, I was not saying anything actually. I was waiting for you guys to answer.
चलिए मैं सर बीच में नेटवर्क प्रॉब्लम हो गया था तो शायद नहीं सुनाई दिया होगा तब.
So tell me the
Done, sir.
Very good. So what is the answer?
Sir, R is equal to NR1 minus MR2
equals to,
upon N minus M.
once again, R equals to
R is equal to NR1
M
and
R1 or M R2.
Sir, NR1 and MR2.
Okay, okay.
NR1 minus
Okay.
MR2.
Maybe, yeah, maybe that's my mistake. Yeah, I have taken other way around. That doesn't matter. So NR1 minus MR2,
Upon N minus M.
like this.
Sorry,
Uh,
N minus M.
like this.
Yes.
That's fine. So you can take minus common. Huh? Now this looks better, right? Because M is bigger, na? So big minus small.
Yes, sir.
Okay, anyway, that doesn't matter. So now as a formula, this is easy to remember. And you are derived using the basic concept of triangle law and a bit of manipulation, right? So anybody else getting the answer? Rugved, Prashansha, Shreya, tell me. Are you guys getting the answer?
Yes, sir. MR2 minus NR1 upon M plus
Yes,
M
same.
minus.
Okay, very good. And that's not difficult, right? So you know how to derive. So next time, even if you forgot, you know what to be done. Remember the basic step. Don't try to mug up anything. That's how we deal with physics. Okay. We don't try to mug up things. We try to find the simplest thing, which is called derivation. And through the derivation, we try to derive the answer. In case you again forget, because the knowledge is volatile, you're going to forget it. You need to learn the derivation so that next time when you have no idea what was the answer, take your pen and paper, write the basic steps, and come back to the answer. That's how we reproduce the answers, and the brain is clutter free. Now you don't need to mug up anything because this is just a first chapter. You may end up mugging up many things, but it's a long journey, and we cannot store everything in the brain. If it is in the information form, if it is in the derivation form, there are very few concepts in physics, and therefore hardly 1 kilobyte of memory of brain is sufficient to deal with the JE physics. But if you try to remember, it will go to GB. The kilobyte to gigabyte, you can imagine the difference. Okay, let's do something. So, of course, there are many applications, but for that we need to learn something more. And one application which I like a lot about triangle law is called the Lami's theorem, the equilibrium problem. Okay, so we should do somewhat of equilibrium problem. So our next heading will be equilibrium of. So I'm going to give you the glimpse of something called Newton's laws of motion. So what do you mean by equilibrium of forces? It simply says that given any random object, so let's say this is some random object, and let's say multiple forces are acting on it. You may name it F1, F2. So what we mean by equilibrium? The equilibrium refers to in physics as the state of a body is not changing. Now, generally, when I say the word equilibrium, many of you may end up thinking something at rest. The physics never says about rest or motion. What physics says that a body in equilibrium will not change its state of motion, which means if it is at rest, it will be at rest. But if it is moving with some velocity, then that will be maintained. That will again not change. So whether you are at rest or you are moving with uniform velocity, if forces are in equilibrium, your state will be maintained. That's the meaning of equilibrium. So how to understand in physics what is the equilibrium? We say a condition in which body doesn't accelerate. Okay. So what we can say, what is equilibrium? What is equilibrium in physics? What we can answer? A condition in which the state of motion of body remains unchanged. That is, it doesn't accelerate. So if it was at rest earlier, then it will remain at rest, or if okay, if it was moving with uniform velocity, then it will continue to do so. Okay, so that is the meaning of equilibrium. Equilibrium does not mean something must be at rest. Let's say a body is under the action of multiple forces, and after the application of force, body is not showing any change. It is neither accelerating nor decelerating. So whatever the state in which the body is, that is maintained. So we say that these forces are creating zero resultant. Okay, it means effectively they cancel out each other effect. So if a number of forces or better I will type it. If number of forces acting on the body is at equilibrium, then the resultant of all forces must be zero, which simply means if you add all force, it will give you zero resultant. So now from parallelogram law, from polygon law, because we have multiple force. If all force will have zero resultant, what does it mean? That the tip of the last vector is coinciding with the tail of the first vector. So essentially, you cannot draw a line between the beginning and the end because the beginning and end collapses together, and that is why it always gives a closed form of polygon. So such scenario will always create closed form, which means you can see F1 is like this. You can do F2 like this. You can do F4 like this. And the F3, F1, F3 like this. And the F4 may be coming back to this point. And you can see the beginning and the end is coming here only. So where you start, you end up there only. So there is no gap between the beginning and the end, and therefore there is no resultant. So in another way of thinking is, if the polygon is a closed polygon, it means there is no resultant. So you cannot join the tail of the first to the tip of the second. So anything which is closed represents zero resultant. Okay. So that's the idea. So how to write mathematically? So mathematically we write F1 plus F2 plus, now here we have 4, but it could be more. And we equate with the null vector. If you remember the null vector, the mathematical equivalent of 0 in vector world of vectors, right? So null is of course meaning nothing, but we cannot write a number 0. We have to use a vector notation. And to our rescue, the null was a synthetic vector which we designed so that our world is consistent in terms of mathematical writing. Okay. So are you guys getting the idea what is equilibrium of forces?
Yes, sir.
Yes, sir.
So if I draw some diagram and if I ask you resultant, you can just tell me the answer. 1, 2, 3. What is the resultant?
0 vector.
Yeah. So if I ask you what is F1 plus F2 plus F3, the answer is null vector. It's nothing. Because the beginning and end is coinciding. Similarly, if I draw a square kind of thing, and if all arrows are cyclic means they never end. So you can see the end and the beginning both are coinciding everywhere. And therefore again the resultant will be
Null vector.
null vector. So all these things will give you null vector. As long as it's closed polygon, simply represents null vector. Now just be careful, don't write 0 number because we are adding vectors, so we will be expecting a vector answer. Okay. So even when a human being will die, they will not become animal, they will remain human being, right? So whether they have life or not, they are human being. They will not transform into some animal or maybe cat or dog at the time of death. So even when the vector is null, it is still a vector. And that's why the distinction from the number 0 should be maintained. So don't get confused between 0 and null vector. They are not same. Understood? So the left side may represent a brick, and the right side you can may assume it's a dead person. And brick is not equal to a person who has died. I hope the meaning is clear. Okay. So we will be returning back to this concept after learning a new concept. So what is our next concept to be learned here? And now the physics begins. So you may call resolution of vectors, you may call component of or components of vector, or you may call effect of vector. So to demonstrate what I'm trying to explain, let me give you a very nice simple example from your childhood. I hope you might have played or may not be, because nowadays the childhood has changed drastically. Maybe this example belongs to my era. So we used to play with the toy card. Let's say, I mean, I don't know whether I played or not, but that's very common. So you might have the toy card. Now you have the remote card or the Lego. Oh, so that's my time. So this toy card is generally we used to pull using a thread. So when you pull this toy card, you pull by applying some force like this, correct? And if you pull like this, how the toy card will move? In this direction or horizontal?
Horizontal.
Right. So that's a very common experience. It will move horizontal, isn't it? All right. Now imagine if the same toy cart is pulled not like this, but something like this by a small force, not very large force. If I pull exactly upward, will it move like horizontal now?
No, sir.
No, it's not possible. So what you conclude from this simple discussion? That this force is not capable of creating any effect in this direction. Am I right? Whereas this force is creating some effect in this direction. And that effect is actually bringing the motion into picture. So we are able to pull the cart in the horizontal direction towards the right, because the way I was applying force having at least some effect in the horizontal direction. So what does it mean? That a force acting in any random direction is capable of producing some effect, even in the direction where it is not acting. Once again, a force acting in any direction is capable of creating effect even in the direction where it is not acting, except which direction? Can you guess? Difficult to guess, but you can guess. Tell me, F1 is not able to create effect in which direction? In the horizontal direction, right?
Yes.
The whole idea is every force cannot affect its effect in the direction perpendicular to itself. Simple. So imagine a horizontal ground. That's better. Yeah. And this is the, let's say you're playing a carom again. If you hit the coin like this exactly at the center, it will go this direction. But what if you hit like this? If the striker is hitting this way, so now it will go like this. So the way you are going to hit it will go like this. Now, if something is moving this way or something is moving this way, So imagine we have, this is x coordinate and this is y coordinate, and the z axis is perpendicular to the plane. Let me remove this part. If something is moving entirely x, let's say if I'm moving in the direction parallel to x-axis, what will change and what will not change? Tell me. So which coordinate will change and which coordinate will not change? As this point will move further and further, which coordinate will change and which will not change? X will change, yes or no?
Yes, sir,
Yes.
it will change.
What about the y coordinate? Change or not change?
It will not change.
Very good. Similarly, if something is entirely moving parallel to y-axis, so which coordinate will change and which will not change?
Y will change and X will not change.
Excellent. So what does it mean? That if someone is moving along the x-axis, the y component is not changing. So I can say the motion have no effect in the y direction. And if something is moving parallel to y, what we say? The motion will have no effect in the x direction. So what happens if something moves in between? So if the initial value is x and y, after moving, which component will change? Both or x or y or none?
Both.
Both.
Very good. So we say that if the motion is neither parallel to x nor to y, but it is happening in the plane of x and y, such motion is capable of changing both the components. So we can say such vector will have effect along the x also and along the y also. The only direction in which you cannot have effect is called perpendicular to itself. Like if you throw something in a direction, the only thing that will not change is perpendicular to the direction. So for example, if I draw, look this carefully. If I draw a line which is a right angle to the pink line in the same plane, as a result of motion, are we changing the coordinate along the green line? Think of the pink and the green scenario. As you move along the pink line, are we changing the anything over the green line?
No.
No. This motion is not creating any change in the green line. Every motion, every force, every vector can create effect except the direction which is called mutually perpendicular direction. In your perpendicular direction, or in terms of mathematics, we call orthogonal. Orthogonal you can say, or perpendicular or transverse. There are many names to it. If something is moving in a given direction, it can produce effect in all directions except the perpendicular direction. So that is why if two vectors are mutually perpendicular, so what is the most interesting thing about this or such vectors? If two vectors are mutually perpendicular, then they are said to be mutually independent. So two vectors which are mutually perpendicular are mutually independent. What does it mean? They cannot influence each other. They cannot create effect on each other because they are mutually exclusive. So there is a very famous line in mathematics: mutually perpendicular vectors are mutually independent. And that is not something a coincidence. The entire idea of the Cartesian system in mathematics, that was designed because it is a common experience that mutually perpendicular directions are independent directions. So every event happening in such direction cannot affect each other, and that's why they are mutually independent. So whatever you do in x direction and whatever is happening in the y direction, that will happen independent of what is happening in other direction. And that independence is the backbone of entire mathematical theory. So the entire field that we are going to learn in further is based on this criteria, that mutually perpendicular directions are independent. This independence is the core idea of learning the resolution of vector, because they are mutually independent. So let's see how we do it and how to develop the intuition about the same. So for the sake of intuition, we choose the force. So I choose some random coordinate system and let's name it x and y. The fact is, you can choose your own mutually perpendicular direction and express your answer. Okay, so there is no like foundation that you're supposed to do like this only. But let's say if this is given to us, someone has said, okay, do it for this as of now, and when you have your turn, you can do in your choice of x and y coordinate. So right now, this is the xy plane in which an object is kept at the origin. So let's say some object is kept here. And then you apply a force on this object like this. Even though it's a force in vector, the length represents what? The magnitude of force. Let's call it F, and F is the vector. F is the length, F is a vector notation or the name of this vector. And now what you can do is you can draw a perpendicular from the tip of the vector to the x-axis. And that's done. And now is eventually this forms a right angle triangle. You can name it A, B. And what else is given to us? That this angle is theta. Now that's pretty easy. Tell me guys, what is the length OB representing? What is the length OB representing here? We call component of F in the direction of x-axis. The other way of thinking is how profound or how effective the force is in the x direction. And we can say for sure that it must not be 100%, right? If the force is acting along the OA direction, will it create equal effect in OB or less effect? Tell me. So as you change from the original direction, the effect will decrease or increase?
So decrease.
Exactly. And when the effect becomes zero? When you turn by 90 degrees.
Perpendicular. Yes.
Very good. I think not everyone is coming to, is with me. Like, are you guys with me? What I'm saying?
Yes, sir.
Yes, sir.
So force is a vector acting in certain direction called OA direction. My question was, if you turn from that actual direction of force to any other direction, do you expect a lesser effect or a bigger effect or equal effect? What do you expect? As you turn away from OA, the effect will decrease, increase, or remain same?
Or decrease.
Definitely. From the original direction, as you move away, the effect will be lesser and lesser. And that's logical. Okay. Imagine the effect, because you guys like football, let me give you the example of football. Okay. So let's say this football is in a ground and there are two players who are kicking the football at the same time, the opponent team and the you. So you give a really big, or you can say large kick, hard kick you can give, and someone is giving a small kick in this direction. Now after these two kicks received by the football at the same time, what do you expect the motion of this football? Will it go this way or something in between? How the football will respond?
In between.
And which effect seems greater, the upward or the right?
Upward.
Upward.
They're upward.
So we can say that it will have bigger effect in this direction and the lesser in this direction, right? Can we say like this?
Yes, sir.
So
Yes.
how to express it mathematically or graphically? So every effect we can name it, let's say velocity. So let's say the bottom kick gives you a velocity of 10 meter per second, but the blow in the right direction gives you a velocity of only, let's say, 3 meter per second. Now if you draw exactly like this, the resultant is pretty easy, and I hope you know what is the result. Complete the parallelogram. The moment you express everything in vector, you're done. And once you do this, you can see the actual motion of the football, which I represent by the V vector, is actually creating a bigger effect in which direction? Upward direction, and the small effect in the horizontal direction. Do you see that? So which angle
sir.
is bigger? Which angle is bigger? Alpha or beta? Which angle is bigger?
Sir, beta.
So can we say that as you go, away from the actual direction by bigger angle, the effect will decrease? Can you see that?
Yes, sir.
Because when you're turning by alpha, you're getting a good enough effect for 10. But if you turn by beta, the effect decreases to 3 only. And clearly you can see that beta is away from the actual direction than alpha, isn't it? So that's the reverse way of thinking, that if you turn away from the vector, what do you expect? Always a lesser value than the actual. Am I right? Am I right, guys? Yes or no?
Yes, sir.
So
So the V vector will have two components. So these 3 and 10 are called components of vector. So a vector will have how many components? Can you guess how many
Two.
components? Pardon?
2.
A vector can have infinite components because you can turn by infinite direction, right? So how much you can turn from the original direction? Any angle. How many angles are possible in the universe from 0 to 2 pi? or 0 to 180 degree? How many angles are between 0 to 180 degree? Answer is how many?
Sir, infinite.
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 So number of possible direction of rotation is called the number of components. So a vector is capable of creating infinite components. Are you interested in the infinite component? The answer is no. So what you are interested in? You are only interested in the mutually perpendicular component. That's it. So out of infinite choices, you are picking a random two choices. What is the specialty about these two choices? The answer is these two choices are mutually perpendicular. And why this is called a good choice? Because these two components are mutually independent. But why that is important at all? Why mutually perpendicular components are so important? Come to the picture on the left. If you look at the left picture, is it a triangle? So can I say OB and BA, the vector sum is OA vector? Can I write like this? My famous triangle law. Am I right, guys?
Yes.
But if you look on the LHS carefully, very carefully, in fact, OB and BA are a very unique one. Why they are unique? Because they are mutually perpendicular. See, that is the idea. The OB and BA are mutually perpendicular. So why this is so important? Because the OA is a vector which can be created by using these two mutually perpendicular vectors, which means these two together, very careful, these two together can produce the same effect that this one alone. And these two is capable of creating this vector. So I can replace this by these two values. Now the best thing is this will have no effect on this and this will have no effect on this. So whatever is the value of OB, that will remain fixed, and whatever is the value of BA, that will remain fixed, because OB cannot create effect here and this cannot create effect here. So why component is important? Sometimes we are not comfortable with vectors like this. And why we are not comfortable, you may ask. So let's say we have another vector like this. Can I add these two vectors by writing like this? It's difficult. Why? Because the addition or subtraction, we know only for numbers, not for the directions. Can we add north with northeast? Can we add east with south? The answer is no, we cannot add it. But what if we know the effect of each force in one particular direction? Then I can add all such effect. Let's say a third guy has come and hits the same football in the same direction like this. Now this effect and this new effect will add up because they are in the same direction. Am I right? So how the vectors like can be added? Of course, vectors cannot be added. You can just write it, but you cannot get the answer. So for example, if I say A vector plus B vector, are we adding anything? Is this any addition? No. This is simply a representation of two vectors A and B. Because plus, how we read the plus sign? And A and B. I hope this was discussed in the previous lectures. So when someone is writing A plus B plus C, is he adding something or writing something?
So writing something.
He is simply writing. This is a piece of literature. Like you say, I love my India. You are not doing anything for India. Okay. By saying I love my India, are we loving the India really? No. You are saying it. So when you really love India, when you do something for the country, in one way or the other way. So you create some scientific discoveries which help the nation in building some advanced technology, or you become a great doctor and serve the people, you become great engineer and create a great missiles and whatever. So ABC is like shows your intention, you love India. But we cannot do anything mathematical until these are numbers. So in physics also, component is like when you convert a vector into its component, and those component which is having same direction, you can add them together mathematically as per the basic algebra, the algebra which you know. Now what we are learning is called vector algebra, which we don't know. So vector algebra is pure a literature, a piece of literature that we have designed with some symbols. What happened when we were designing this mathematics called algebra, we borrowed some symbols from the old algebra, the linear, the algebra which you know, the algebra. Now we are using what those symbols back into the new world called vector algebra. But keep in mind that while bringing these symbols, we never brought the meaning. We gave the meaning entirely new to the set of these symbols. So don't get confused between the symbol that we use here and the symbol that you saw earlier in your mathematics syllabus so far. So the vector algebra uses some symbol for the, you can say, sake of writing one, just to make it shorter. But the meaning was not borrowed. We never borrowed the meaning actually. So intuitively, you may get confused between the A plus B and 2 plus 3. A plus B is a literature, 2 plus 3 is a proper something called mathematical operation. So of course, A plus B writing is called a vector operation. And you want to convey a meaning to the world that A and B coming together will produce a new effect. So a resolution vector is a way to understand the effect the vector can create in a given direction. And why this is important, we'll come to know this very soon. So, okay, anyway, coming back to this question, because let's solve it. If F is the length of OA, what is the length of OB? So what is the OB length? Just length. For length, you just use trigonometry. What is OB length, guys? Tell me. Don't think as a vector, just think as a length. The length of OA vector is F. This is the length of OA vector, correct? So what will be the length of OB vector? Can you tell me? Which trigonometric identity will help you in getting OB?
So cos.
F cos theta.
Very good.
Cos theta.
Very good. So F cos theta is what? Try to understand. Don't try to mug up, because most of the case what happens I have seen is students simply mug up the cos theta and sin theta. What is F cos theta? The component of F in the direction of X. Then don't mug up. Try to understand how you are finding the component. To find the component, what you do? You drop a perpendicular from the tip of the vector in the direction in which you are trying to find. I hope this part is clear, what I'm trying to say here. F cos theta is the component of vector F in the direction of X-axis. And how far is the direction from the vector in terms of angular, I mean, because angular distance. At what angular distance the x-axis lies? Try to understand this. The theta is representing the angular distance. You can think this way. So what is the angular distance of the force from the x-axis? Tell me. Theta is the angular distance of the force F with respect to x-axis. So what is the angular distance of the F from the y-axis?
90 minus
80
theta.
minus theta.
Exactly. So to know the component of a force from the y-axis, you have to take which angle? Cos of which angle? 90 minus theta. So the AB is basically representing, let's call it BA. So the length of BA is same as length of OD, correct? Tell me guys, can I say that the AB is same as OD lengthwise? So what is BA? You can use that again, basic trigonometric identity. What is, again, tell me BA?
F sine theta.
And can we say F sin theta is nothing but the F cos of 90 minus theta? Why? Because cos 90 minus theta is also sin theta, right? Do you know this relation,
Yes, sir.
the angle relation? Like sin 90 minus theta is cos theta. Anyone who doesn't know this relation, just let me know. So you all know, right? Everyone knows.
Yes, sir.
All right. So now coming to this, you got OB and BA length, and you're saying these are components. So what is the way of finding the component? You take the vector, you take the cos of angle between the vector and the direction. That is the meaning of component. It is not sine and cos, it is only cos. So how to find the component of a vector in a given direction? Check the direction, check the vector, take the cos of the angle between the vector and the direction. That's simple. Am I clear? Am I clear, guys?
Yes, sir.
So don't try to remember this way that one is cos, other is sine. No. Let me give you some more practice. Here you can see, coming to this question, alpha and beta are two angles. Let's say the length of the vector is V. Okay. So what is the component of vector in the upward direction? Let's say, what is the y component? Can you tell me what is the y component? So V, and how far is the y axis from the actual direction of V in terms of angle? You can see alpha away. Am I right?
Yes, sir.
So take cos of the angle, that's it. And this is called the y component. Y component. You can write like Vy. Similarly, what is the x component?
V sine beta.
No, V cos beta. You have to take the cos of the angle from the given vector to the direction. That's it. There is nothing like sine. Just because two mutually perpendicular directions will have a complementary angle, that is why this will become automatically V sin alpha, right? You're not getting it. Beta is what? 90 minus alpha. So the cos beta will be cos 90 minus alpha, which is sin alpha. I'm trying to break the barrier of sin and cos. Don't get trapped in sin and cos. Just remember, there's only one thing in life. It's only cos. So to find the component of a vector in a given direction, what you do, you look at the force, look at the vector, and then you ask yourself, how much I need to turn to align myself in the given direction to get some answer. Take the cosine of that direction, that angle, that's it. You're done. No need to mug up the sine and cos. That is what I'm trying to explain here. I think you're not getting it. Okay, no problem. Let me give you one better example. This will help. What is the component of f vector in the direction of orange line? Can you tell me? Find component of f in the direction of E cap. Tell me that. What is the answer? So how you find the component in a given direction? The answer is take the force. Am I audible, guys?
Yes, sir.
Yes, sir, you're audible.
So tell me how far is the E cap from the actual force in terms of angular distance?
Alpha.
How far is the E cap from the F, the force?
So beta
Look
minus
at the
alpha.
diagram. Yeah, exactly. I think this is not clicking with everyone. You have to look for the angular distance. You're not getting it. I'm asking the angular gap between the vector and the direction. So what is this gap? Beta minus alpha. How many of you are agree with beta minus alpha or have realized, okay, yeah, this is the right answer? Tell me, guys. Anyone? I think Siddhant has understood. Shreya,
Yes, sir, I will.
Prashansha, Rugved, you got the idea?
Yes, yes.
So the F is, and the E vector, the E cap is having some angular distance. They are away from each other by some angle. When I say find the component, I'm teaching you something more advanced. Just remember this. You will never get confused in life. Component only means taking the cos of the angle. That's it. Don't mug up as sin and cos. That will be very, very dangerous. Because normally you shouldn't remember as sin and cos. Component means finding the effect of force in the direction. And it comes from the only angle. By the way, what is the component of F along the y-axis? If I ask you what is the Fy?
For f cos 90 minus beta.
Exactly. No confusion. What is fx? What is
Sir,
fx?
f cos beta.
And you're done. And see, isn't it easier to remember than to remember as sin and cos? Okay, maybe you will not agree with me. Anyway, not an issue. So let's say I throw a football or a ball in air with a speed v at an angle theta. So what is Vx? What is Vx?
F cos
Sir,
90 minus theta.
Now here we have the V as the vector. What is Vx? I'm not using F symbol, I'm using V symbol. What I can write here?
V cos 90 minus theta.
Exactly. So what is the Vz?
v cos theta.
Simple. Is it sin and cos or it's logical? It's not sin and cos, right? Now this idea is very, very powerful in kinematics. If you don't understand this, the entire chapter of projectile motion will be difficult for you. Let me show you something more. And this is from the advanced projectile motion. And see how powerful is the idea. So you may be throwing something like this, which makes an angle theta with horizontal. I'm taking horizontal as x-axis. So you can see them two mutually perpendicular directions. X dash, y dash, which are again mutually perpendicular, and x and y. You're supposed to answer four things: Vx, Vy, Vx dash, Vy dash. Okay, guys. So tell me the values of these four variables.
So Vx is V cos theta.
Excellent. So Vy is
V sin theta.
excellent. So what is Vx dash?
V cos theta minus alpha.
That's correct. And what is Vy dash?
Sir, v sin theta minus alpha.
Absolutely correct. Do you realize the meaning of cos value? Why I'm saying remember only one thing? Because you're not only supposed to resolve along the typical horizontal and vertical. You can have any direction. And this idea will be really powerful and helpful. I think many have not understood the previous part. So anyone having difficulty in these four parts? Rugved, Shreya, and Siddhant, you understand. Rugved, you got the idea?
Yes.
Shreya?
Yes, sir.
Okay, very good. So coming to this part, try to understand the idea. So the idea is this, very typical problem from concept of laws of motion. So something called inclined plane. Every plane will have some theta, the angle of inclination. And we have a block which we keep over the plane having mass m. Our earth is here, the horizontal surface. This is the earth. And how the gravity will act? So you need to know that gravity always pulls towards the center, which means it always pulls normal to the surface like this. So gravity always acts vertically downward. This is the vertical downward direction. Is this clear?
Yes, sir.
Okay. And now let's say the way of writing of the force of gravity is m into gravitational acceleration g. Yeah, the same g which you know, it's very famous, 9.81 meter per second square. So now if I ask you, and if I make some direction, we are learning the vectors in practical way, not just as a some formula, some chunk of formula and we are done. No, you have to understand the vector for the purpose of physics. So I'm calling this as x-axis and I'm calling this as the y-axis. The only relation between x and y is they are mutually perpendicular. How they are, we have no control. The only condition is they should be mutually perpendicular. So what is the component of gravity? Let's name it Fg. What is Fgx and what is Fgy?
Or is it mg cos theta?
Mg
Cos theta.
or Gx?
Yeah.
Think about it once again.
Sir, FG 90 minus theta. FG
Yeah,
cos 90 minus theta.
exactly. So you need to find the angle first, no? So what is the angle between the gravity and the x-axis? This is the angle. And you can extend this line. This is 90. This is 90 minus theta. So what is the component? Mg into cos of the angle which you see. And I see this answer is. Okay, this is slightly difficult or interesting. What is Fgy? What is Fgy? Tell me guys, this is not difficult. Come on. What is FGY?
Sir, FG cos 180 minus theta.
G cos is the right answer. Exactly. And you will learn that this will become minus mg cos theta. But that's a different story. But that's correct, because if I'm asking the y-axis FGY, which means you have to go from all the way from here to here. So that is the y-axis, right? And you can clearly see this angle is how much? 90 minus theta plus 90. Am I right?
Yes, sir.
And minus is saying something, that it is saying that, okay, it is opposite to the y-axis. So the value is this much in the direction exactly opposite to y, which means this will have component of value in this direction, and this value is how much? This value mg cos theta. Understood? That's the meaning. So you can interpret the negative thing. Negative means the component is having same value but exactly opposite of what you were expecting. Understood, guys? Yes or no?
Yes, sir.
Okay. So if components are negative, don't get worried. Rather, you can take the component in the. So now coming back to the same question. If I do not mention the x and y axis, if I simply tell you that this is theta, this is the mg, just replace the block by a line. And I'm asking you, can you resolve in the two mutually perpendicular direction, this and this? Simply resolve in the direction, these two directions. So we always look for the acute angle. We don't look for the obtuse angle. So in which quadrant, if I call this as, let's say, x and y, this lies in which quadrant? Third quadrant, right?
Yes, sir.
But it really doesn't matter. What matter is, so we have seen that this is 90, this is how much? 90 minus theta. So this will be how much? Theta. Okay. Now the quadrant is visible to you, so you know that this vector will have component in that quadrant, which refers to this direction and this direction, isn't it? So mg will have only two components in the mutually perpendicular direction. Not only two, it means two in the given direction. One down the plane, another normal to the plane. Do you realize this? Down the plane thing and normal to the plane.
Yeah.
So what is this component? This one. Tell me. What is the component of gravity in the direction perpendicular to the plane? Tell me, guys, what is this green one? The component of mg in this direction is how much? In this direction.
Sir,
I'm not
FG
saying
cos
x
theta.
and y. Mg cos theta. We always look for the value, and therefore we look for the direction which is nearest, the acute direction. We don't look for the obtuse direction. Similarly, what is the component of mg in the downward direction, down the plane?
mg sin theta.
Exactly. So gravity is capable of pulling it down and pulling normal to the surface. Now, in which direction the block can move? Down the plane or normal to the plane, or both? In which direction the motion is possible? How the block can move?
So downwards.
Down the plane.
Down the plane, right? Because the surface will not let you go inside, right?
Yes, sir, down the plane.
Okay, so who will balance the, because see, mg cos theta is trying to pull, but is the block going in that direction? Mg cos
sir.
theta is trying to pull the block, but is it possible for the block to move in that direction? Yes or no?
No.
So the surface will try to stop it, right? The surface will try to stop it, isn't it?
Yes, sir.
So the force that the surface will apply on the block to stop is called normal. What we name? We call it normal reaction. So who will apply the normal reaction? The surface on what? Block. Okay. Are you guys getting it? What is normal reaction? So now you can see that normal is a force which surface always applies. And how normal is applied? It is always, it will push you away from the surface. That's how normal is applied. Normal is a push force. It only pushes the object. Is this part clear, guys? Yes or no?
Yes, sir.
So in concept of equilibrium, in which direction there is no motion taking place or not possible? You can say the direction perpendicular to the surface, right? So the direction perpendicular to the surface motion is possible or not possible, guys? Tell me. In this direction motion is possible or not? Yes or no?
No, sir.
So the direction in which motion is not possible, can we say the forces in that direction is in equilibrium? Can we say? The answer is
Yes,
yes,
sir.
we can say. And that is why we can add these numbers n. If you take n as positive, the mg cos theta becomes negative. And therefore the sum of the vectors like this will be 0 because they are at equilibrium. And from there we get the idea that n is mg cos theta. We'll come to that again later on, don't worry. But just I'm trying to explain, if you can understand here, that's really good. So we'll come to that once again. Now what about the mg sin theta? Is it balanced? Is it balanced? Okay. Before I move forward, tell me guys, normal and mg cos theta, will they have any effect in the direction of motion of the block? Yes or no?
So no effect.
Anybody else want to say something? Do you think that normal and mg cos theta can produce effect along the plane?
No, sir.
No, that's impossible because these two directions are mutually perpendicular. And that is the whole idea, that what normal is doing, what mg cos theta is doing, has nothing to do with what mg sin theta is doing, because they are totally mutually perpendicular. And that is the purpose of learning the component. By creating two mutually perpendicular component, we can check the event separately. I need not to bother about mg sin theta while dealing with the forces in the direction normal to the surface. And while dealing with the forces along the surface, I will totally ignore what these guys are doing. And that is the way we separate the values in two different segments, and we deal with each segment separately, which is quite easier. So that is how we separate the concern. What X will do, the Y will not interfere. What Y will do, the X will not interfere. This independence is the key to learn the laws of motion. If you understand the meaning of independence, you will appreciate the laws of motion. I'll give you some more example. Look at this example. So from a ceiling, let's say you're having a birthday party, you attach some surprise gift from the ceiling using multiple threads. And these three threads are joined here at a common point. And you attach some box here. Let's draw the box. A nice small box. Okay, so now we have box. You can see here. Let's say this angle is alpha, that the string on the left is making. This is beta. The third angle is not required, because if you know two angles for triangle, I hope you know how to find the third angle. Correct? So in triangle, generally no one will give you three values. Two values are sufficient. Now, if we hang something like this, what do you expect? These strings will be taut or loose. These are called strings. String one, string, or you can say thread. 1, 2, 3. So we have three separate strings which are joined together, and something is hanging. So what do you expect? These strings are taut or loose? Am I audible, guys?
String 3 will be loose.
Okay, you think string 3 will be loose? Why?
Because it has a present weight at one end.
So it will be pulling it everything down, no? So it will, must be taut, no? Why loose?
Yes, yes.
So it must be taut. I don't think it should be loose. Okay. Is this clear?
Yes, sir.
So all string must be taut, no? I mean, that's common sense. Everyone is pulling, and the problem with the string is they cannot extend their length, so they become taut. And taut string creates a force that we call tension force. There is a name for this, tension force. And what tension force does, it will try to pull the ends. So if a string, if you consider string 1, The string 1 will have two ends, this end and this end. So tension having only one role to play, it will only pull you away from the ends. For this string, the tension will pull this end and this end like this. For this string, it will pull down and up. The only job of tension is to pull, not to push, unlike the normal reaction. So in the laws of motion, of course, we are going to learn in detail, but a very small idea or a brief idea, let's develop here in vector. Okay. So considering this point, the circle point, I would like to draw the force acting on the circle. So imagine there is some hypothetical object at the circle, inside the circle. So that point is experiencing how many forces? Tell me. How many forces are acting here? Tell me, guys. On this joint, this knot. Okay, when I say string is taut, what is this spring of taut?
So tension.
Yeah, I do know the spelling of taut. I mean, how to write it? TA. Like this, taut, right? I hope so. This is the right answer.
Yes, sir. Sir, I thought you were saying tight or something.
No, the tight word is not the word which we use here. Like tight is used for clothes. Like when you have the clothing you're wearing, then you say tight. In string,
sir.
we use word taut. Okay. And this is the right spelling. And why I use this word intentionally, because in the very beginning, you will also have the same idea that tight and the taut are not the same. So tight is only used for the clothing, not for the string, right?
Okay, sir.
Like the lid of the jar is tight. So it's closely packed. Okay. So the idea of tension is it is a pulling force. It pulls the object concerned. So I'm concerning the circle, and I can see there are three separate branches coming from the circle. All will pull this point like this, and like this. So can we say the tension as T2, T1, and T3? So I will draw this diagram separately. And such questions in physics are very common. You know what we call this kind of problem? This is called naughty problem. Oh, I just made this knot. This is called knot. Okay. So at this knot, how many strings we have? At this knot, we have 3 strings, right? See, no one is going to tell you that how to solve this question, but given the idea of vector, one should be able to judge that I have to draw these diagrams. So the moment I draw diagrams like this, I have the proper X and Y coordinate system. And once we have the X and Y coordinate system, can we find the angles like these angles? Is it possible to find angles? Probably if you look at the original picture, you can understand. Can you find these angles? Tell me, guys. Can we find these angles? Yes or no?
Yes, sir.
So how
Yes,
much
sir.
is the left angle? How much is the left angle?
Sir, alpha.
Correct. That's alpha. And the right one is
Beta.
beta. So this angle is how much? Just in case if you want. So this angle is 90 minus alpha. And this is 90 minus. What is the angle between the vertical line and T3? So if a direction, if you coincide with the x-axis, what is your angle with the x-axis?
So 0 degree.
Sir, 0.
Exactly, 0 degree. So whenever a vector is parallel to the direction, we call 0 degree. That's correct. So now what is your job here? Let's say I'm asking you to do something. Find T1x, T1y. Okay. Find T2x, T2y. Find T3x. And this is not very difficult. You can do it. So can I do this?
Sir, we can say it orally also.
Yeah, just tell me already. I mean, that's it. In terms of course, T1, T2, T3 in symbolic form. So what is T1x?
So
See,
T1x is
Yeah,
T1 cos alpha.
with minus sign. Why? X is on the right, but alpha is with minus x-axis, right?
Yes, sir.
So whenever you see the angle with the opposite direction, take the answer, put a minus sign, because I'm asking T1x, you are getting T1x dash. That's totally okay. If they're opposite, just change it. So that's how we represent mathematically. So what is T1y?
Minus T1 sin alpha.
T1y. The nearest direction is y only, no? The angle between T1 and y is obtuse or acute?
Sir, acute.
So every acute angle will give you positive answer. No? It means, see, it's simple. Think that as an arrow, turn towards y. Is it easier to turn towards y or turn towards y dash? Which one is nearest? From T1 to y or T1 to minus y, which one is nearest?
So
T1
T1
to
to
y.
y.
So if y is nearest, then you can get the answer directly, no? With
So
plus sign.
T1 sin alpha.
Correct. T1 sign, that's right answer. Very good. Now, okay, Rugved will tell me the T2x and T2y.
T2x.
What is T2x?
T2x is T cos T2x. T cos beta.
That's right answer. Because that is the angle between the T2 and the x-axis, right?
Yes.
And what is T2y?
T2 cos 90 minus beta.
Which is sin beta, right?
Yes.
Okay, Shreya will tell me. What is T3x? What is T3x? Tell me. Tell me, guys, what is T3x?
Sir, 0.
Shreya, are you there? No.
Yes.
What is T3x? I was asking you a question. What is T3x? The angle is 90, na? So you can add T3 cos 90, which is anyway 0. Or by common sense, because these are mutually perpendicular direction, it cannot have the component, right?
Okay, sir.
What is T3y? Only Shreya will tell. What is T3y? What is T3y?
What?
Okay, how much?
What?
T3y value is how much? Okay, anybody else? Siddhant, what is T3y?
Minus T3.
Minus T3 is the right answer. Very good. So it is in the minus y-axis. So the answer is simply minus T3. Or if you want to, you can add T3 cos 180 degree, right? Because you have to turn from there to y by 180, right? Isn't it? To go from here to here, 180. And
Okay,
then
sir.
you have the answer, minus T3. So when the directions are parallel to the axis, it's very easy. No need to resolve. You have to just add the value plus or minus. Only when it is between the axis x and y, you have to resolve to find the component. Now, why such ideas are important in physics? The components give you the numbers, and numbers can be added together. So all x component can be added together. This forms the one. These all numbers are on the same number line. Which number line? The x-axis. You can call it x-axis. So if you remember the very first lecture, I told you that the summation happens on a number line. And what is the meaning of summation? You work on the number line. You start from the origin, you go left, you go right, and then you land on some number. So I cannot add a number from the x-axis to the y-axis because these two numbers are in the two different directions. So numbers are only added when they are part of the same line. And that's why all the x component represents one family, which can be added numerically. All the y component represents another family, which again can be added numerically. And that is the whole idea of learning the components, because by doing so, you make sure that you can do the algebraic addition, which you know already. Okay. So what I can write? The summation of all x component of tension. This will add up to 0. Why 0? Because the system is in equilibrium. It is not accelerating. So the all x effect is not creating any effect. So individually they have effect, but there is no net effect. Similarly, the all force in the y will be also 0, because again they are not creating any effect in the y. Because if there is an effect, you can see the things will not be at rest at this. Is this clear, guys? Are you getting the idea? What
Yes,
we are
sir.
trying to achieve? So this was exactly the whole idea of learning the concept of equilibrium. That if the vectors are at equilibrium, it means their individual effect will cancel out when you add all effect. And what we need to understand that if you resolve into two mutually perpendicular direction, they create independent effect. So nothing, all x effect will not affect the y effect. Okay. So why this is so important in physics? The entire laws of motion is based on this idea, which says that if the summation of all vector forces is giving you null vector, And if every force can be resolved into two components called x and y, so summation of f vector is same as summation of fx I cap. I made some mistake here. Plus summation of fy j cap. And since this is null vector, then of course this will not cancel this effect. Can these two vectors cancel each other? Yes or no? Is it possible for the x component to cancel the y component or vice versa?
No, no, sir.
Definitely no, because these are mutually independent, right? So when this will be 0, when we can claim that this entire term is 0, we can claim that this is only possible when every independent term is 0 separately, right? Each term must be 0, then only the sum is 0. Are you getting my point? What I'm trying to say?
Yes, sir.
They cannot cancel each other. So when I say the net force is 0, it simply means every component is 0, because one component cannot cancel the other component. So 0 is only possible when each one is independently 0. We can write as 0 I cap, and null vector we can write as 0 j cap, and you can compare. You can see the net force along x is 0 and net force along. So for equilibrium, if the net force is 0, then we can definitely say that their component must be 0. Understood? So if every component turns out to be 0, then can we say the resultant must be 0? The answer is yes, we can say. So we will be applying these ideas further in solving some of the challenging problem of laws of motion. And even though we have not studied the laws of motion as a separate chapter, you can solve all questions of equilibrium with great ease, because of the simple reason everything we can explain in terms of vectors. Okay, so you all can turn on the video for some 1 or 2 minutes. Let me also start. So switch on the videos, everyone. Don't get scared by looking at me. I'm always dangerous. That's why I hide myself. Okay. Rugved. Okay, we have the new intern today, Rugved.
Yes, sir. I'm joining with another device.
Yeah. So now we are entering the world of vectors. Okay, there is an echo actually. So you all should be aware of your like competitors. Okay, don't think they take them as easy. Okay, give them big fight. So you can see these guys you have to eliminate from the examination. So Siddharth had to eliminate all the 3 below. Shreya, you have to eliminate all 3. Except me. I mean, I'm already eliminated from the competition. So that's totally okay. Prasansa, you have again 3 competitors to eliminate if you want to succeed. These are your enemies. Remember, these are not friends. Don't make your competitor friends ever. Okay. So these are your enemies. Be very careful. So now this kind of enmity is good actually. Yeah, Rugved, you can on. You can switch on your video. If you're not scared, you should switch on.
So we can see him actually on his second device.
And I cannot see you. I wanted to see you. Just for the introduction. This is the first day. After some time, you will find myself more dangerous Okay, with time I become like a monster and will try to kill you with problems. Okay, so be very careful. Come with your all homework, solve it, else you will have more problems in your life. Numerical problems, not other sort of problems. Only problems of type called numerical. Okay, so we'll do a lot of questions. I mean, see, we are not going to learn vector in 1 or 2 lectures. It will take at least 7 to 8 more lectures to finish. And through the vector, I will show you the entire physics. The physics which you have not seen as of now, the physics you are going to see, and those things will not be very difficult. Only if you master the vector. Don't take this as a simple chapter, like a chapter, the very first chapter that normally we ignore. That what is the first chapter? Okay, we can do with the rest. This is the most difficult part of learning physics. And if you are comfortable with this part, I can assure you the entire physics is going to be super easy. Okay. So this is a literature, as we discussed. This is a simple piece of literature. And we need to learn how to read it, just like you're learning German or some other language. That's a Mandarin or French is easy, so I will not name it. So these are difficult languages like German or Mandarin or maybe Russian is also a bit difficult. Still, I'm trying to learn. Maybe sometime I'll teach you Russian language or maybe German language. Okay, I'll take a separate lecture for German language. Till then, goodbye and take care.
Bye, sir. Thank you, sir.
Bye, sir. Thank you,
Thank you,
sir.
sir. Bye, sir.
So finally, I can see Rugved is here.